Yes, good morning everyone. My name is Mark. Thank you for joining this webinar. We will start the webinar now. I'd like to turn it over to Ashley. Ashley, can you get us started, please?
Yes, thank you, Mark. Hello, and thank you for joining the webinar today on signaling conversion. I'm Ashley with Pulse Supply, and also joining me today is Mark St. Onge with Telcobridges. Today, our discussion will focus on solving protocol incompatibilities in carrier networks with the help of signaling conversion. During the presentation, if you have questions, feel free to type them into the GoToWebinar control panel. We'll read them aloud and respond as we go. If we've moved to a different slide or we miss your question, there will also be a chance at the end of the presentation to ask questions. So let's get started. During today's 30-minute presentation, we'll provide a brief introduction of our companies and talk about signaling conversion, how it works, and what's required. The presentation will focus mainly on TDM and packet-based protocols. We'll discuss network-to-network signaling adaptations that may be required, and we'll show you some specific signaling converter application examples. Finally, we'll talk about Telcobridges products and where they fit. For those of you who may not be familiar with Pulse Supply, we were founded in 1995 as a distributor of connectivity products. And by the late 90s, we began providing TDM to IP conversion products for our clients, who are typically carriers, large enterprises, and other service providers. Telcobridges is one of our key partners in this area, and we've been solving network challenges with their products since about 2008. Our goal today is to provide information to you that will be helpful and offer solution ideas that allow new technology that's available to operate with the infrastructure you already have, helping you stay within budget. If you'd like more information about Pulse, our background, or capabilities, I can provide that at the end or follow up after the call. But for now, I'd like to hand the presentation over to Mark St. Onge with Telcobridges. Mark?
Thank you very much, Ashley. My name is Mark. I'm responsible for sales support at Telcobridges. Let me just briefly tell you about our company before I get into the main material of the webinar, which concerns signaling conversion. Telcobridges is a Canadian company founded 10 years ago, actually almost 11 years ago now. We're based in Montreal, Canada, and we are a manufacturer of voice over IP gateways, signaling gateways or signaling converters, and telecom solution platforms for carriers, and specifically for carriers. We perform all of our research and development, product design, software development, and production at our company headquarters here in Montreal. Customer service and specifically technical support is provided from our headquarters here in Montreal as well. So let me get into the main subject of the presentation, which concerns signaling conversion, which is the adaptation of signaling protocols mostly on TDM links. As you'll see later on in the presentation, I'll be talking a little bit about voice over IP and packet networks as well. But the main goal of signaling conversion is to adapt signaling protocols or voice coding formats between different networks or devices that are incompatible in order to achieve interoperability and actually produce usable connections between these networks and devices. So for example, you may be faced with the challenge of connecting, let's say, an older CAS device, such as an older PBX, to an ISDN PRI service from a service provider, or you are a carrier and you're able to provide ISDN PRI links but need to connect to legacy devices, or you may be required to adapt between different SS7 signaling variants You may have one network that uses a specific SS7 variant and another network that uses another, and these two are incompatible, so you require a solution to connect these two together. Or you may need to convert between two very different signaling protocols, such as between ISDN PRI and SS7, or SS7 and channel-associated signaling protocol, or you may need to connect devices that to your SS7 network that do not support SS7. So signaling conversion, and specifically devices called signaling converters or signaling gateways are able to solve these interoperability issues and adapt signaling protocols between different networks or different devices. So in the next few slides, I'd like to get into a little bit more detail into what's involved in converting protocols between these different networks. So on this slide here, I'm showing a signaling converter, and specifically a Telcobridges device here, which is connected to two networks, network 1 on the left-hand side, network 2 on the right-hand side, and for some reason these two networks are incompatible, either because they don't support the same interfaces, physical interfaces, or they don't support the same signaling protocols. So when you're looking for a solution to connect to devices or networks that use different interfaces or different signaling protocols, the basic information that you need is what interface type is involved and what signaling protocols are involved. And I list here some of the interfaces that are supported by signaling converters. Those can be T1, E1, or higher density interfaces such as DS3 or OC3. And I list here on the bottom some of the signaling protocols that you may need to support, and that the signaling converter is able to adapt between these different protocols, such as CAS-R1 or T1 CAS signaling, such as E&M signaling, or CAS-R2, which is widely used in Latin America and South America, or ISDN PRI and SS7. So when you're looking for a solution to adapt these networks or devices together, this is the basic information that you need, such that the appropriate solution can be found and provided in order to achieve the connection. In this next slide, I'd like to illustrate that signaling converter is involved in much more than just simply converting signaling protocols. It's actually involved in the transport of the traffic, or the transport of the audio or voice. And what I'm showing here on this slide, I'm showing a signaling converter, in this case Telcobridges TSG3200, which is connecting on the left-hand side to a T1 network, or to a network for which the interconnection uses T1. And the signaling protocol that needs to be supported there is ISDN PRI. And I'm specifically indicating here the NI2 variant of ISDN, or National ISDN 2, but it could be something else like 5ESS or DMS 100, or it can be some other ISDN variant. So the requirement here is on the left-hand side, support T1 with ISDN PRI signaling, and on the right-hand side, the network we're connecting to provides E1 interfaces and uses the European variant of SS7 that's defined by the ITU-T. Now the signaling converter, which is performing the connection between these two networks, has to implement the different layers to connect to the different physical interfaces, and then also implement the protocol layers that are involved in these two signaling protocols, that is ISDN on the left and SS7 on the right. And the signaling converter, of course, implements a call routing engine, which allows it to actually perform the call handling as the calls come into the device. So let's look at both the left-hand side and right-hand side. So on the left here, we're connecting to a T1 network, and typically in the USA, on a T1 interface, we're using BHCS line coding. That could be another line coding such as AMI as well. And the framing on this T1 interface is very often extended superframe. So this is really, this block here shows the physical layer really, which allows the device to connect to the network on the left. And then on top of that, carried by this physical layer, which concern the signaling, we see the different layers here that are required in order to support the ISDN PRI signaling. That is LAPD layer, which actually provides the transport for the ISDN call control messages, which are defined by another standard called Q931. So the signaling converter implements these protocols, Q921, Q931, to actually achieve and understand the ISDN signaling. Now, if we look on the right-hand side, if you recall, there were the requirement is to interconnect using E1 interfaces. So here also we have a physical layer which is different from the T1 interface. Typically for E1 links, we're using HDB3 line coding, and the framing can use CRC4 or no CRC. Here I'm just illustrating the use of CRC4, which allows for a cyclic redundancy check on the E1 frames that are transported. Now the network on the right-hand side uses SS7 signaling. So the signaling converter here implements the different SS7 layers in order to implement the SS7 signaling, and those layers are MTP2 as a transport layer for SS7 messages, as well as MTP3 on top of that, and finally the call control layer in SS7, which is called ISA. And there are different variations of these protocols depending on, let's say, which country or which region the network is located in. And finally, the signaling converter implements a call routing engine, which actually takes call routing decisions on incoming calls and placing outgoing calls on the other network. So the signaling converter is involved in implementing all of these layers and actually involved in TDM switching and the actual transport of the voice or the audio or the PCM encoded voice when we're using TDM links here on both sides. And I'm showing here that the voice is transported at the lower layer here at the physical layer here or the framing layer between the T1 and E1 variants. So I want to use this slide and tell you again that the signaling converter is involved in much more than protocol conversion. It's also involved in TDM switching as well as in protocol conversion. Let me show you here on the next slide as an example an actual call flow for such a deployment where we're converting between T1 and E1 with ISDN on one side and SS7 on the other. Each protocol have their own call control messages which are illustrated here on the left for ISDN and illustrated on the right here for SS7. And the signaling converter or this device, the TSG3200, is involved in converting from one message or adapting one message on one side to another message on the other side. So we see here in this example that an ISDN setup message it gets translated to an initial address message on the SS7 side or an IM message for short. On the SS7 side, a typical response for an IAM is an address complete message or an ACM message, which translates into an alerting message on the ISDN side, and then these messages continue until finally the audio path or the PCM path is able to be established and the call can be handled. Probably in a case like this, the signaling converter is involved in PCM A law conversion to PCM mu law conversion, and then finally, when the call ends, and in this example here, I'm showing that the teardown of the call is initiated on the ISDN side with a disconnect message. You see that that translates to a release message and a release complete and so on. This is a sample call flow for ISDN between ISDN PRI and SS7. The signaling converter is able to adapt these messages, and in fact, you know, on one side, it will collect all of the parameters that are received via the signaling, such as calling, telephone number, called telephone number, calling party category, and many other parameters that it then must adapt and present on the other side, in this case SS7 side, in an appropriate format that is understood by the SS7 protocol. And so this is what the signaling converter does when it adapts between different networks or different devices. There's an opportunity here as well when we're doing this, since these devices implement all of the protocol layers all the way up to the call control layer. There's an opportunity here to do much more than simply protocol conversion. The opportunity here is to manipulate or modify or adapt some of these parameters that are passed from one side to the other. And I'm showing some examples here, such as Telcobridges signaling gateways or signaling converters are able to manipulate the calling and called numbers from one side to the other. For example, it may be required to insert the country code if it wasn't there on the incoming call, or it may be required to remove the area code. Who knows? It's just required to have enough flexibility in order to adapt these different networks. Same thing goes for the caller ID and the caller name, which may be inserted or manipulated or modified when we convert from one protocol to another, as well as the display instructions for this caller ID or caller name. Those can be changed by the signaling gateway. It's also possible to modify or change the redirecting number. This can be interesting when calls are being sent, for example, to a voicemail system where the redirecting number is actually the telephone number of the voicemail for that subscriber. And finally, do some termination cause code mappings between these different protocols. So it's possible using the signaling converter to map cause codes from one protocol to another. So it may be required, for example, that an all trunks busy or all circuits busy message on SS7 be adapted to simply a busy message or something else on ISDN network, or maybe even on a SIP if it's a voice over IP network. So the signaling converter is useful for this as well, not simply protocol conversion. It can help you adapt or interconnect different networks together that have different requirements. So now that I've presented an overview of signaling conversion, I'd like to present a few applications to give you an idea of where these devices can be used. So let me start with this application here. where the signaling converter can be used to interconnect incompatible device, in this case, let's say a legacy PBX that uses T1 CAS signaling or E1 channel associated signaling, specifically R2 CAS, to an ISDN service that's provided from a carrier. So a signaling converter can be used to do this, where it connects on the left-hand side to an ISDN PRI trunk from the carrier and will present a T1 CAS or E1 CAS interface to the legacy PBX. And this allows to interconnect this legacy device to say, a more modern network in this case. Here's another example which is slightly different, where in this example I show how signaling converter can allow you to provide ISDN PRI services off of an SS7 switch. On many older switches, and possibly this happens a little bit more in the USA than elsewhere in the world, the older class 5 switches may be difficult to scale these switches and add the resources or the hardware resources required to deliver more ISDN PRI services. So it's possible to use another device in front of this switch that will interconnect using SS7 to the class 5 switch, but will provide ISDN PRI services to subscribers. So it can allow you to extend the life of your older class 5 switch, or possibly even deploy the PRI services in a more timely fashion than you could on your existing switch. Let me give another example here, which concerns the conversion between one variant of SS7 to another variant of SS7. In this case here, we're converting between a North American SS7 variant that's defined by ANSI to a European SS7 variant that's defined by the ITU-T. Here we're using T1 interfaces on the left-hand side and E1 interfaces on the right-hand side. We have a number of customers that are using our devices to do this in order to interconnect different networks or devices that don't necessarily support the same SS7 variants. Here in this example, I'm showing how the signaling converter can be, say, augmented to support voice over IP. In this slide, I show a TDM network on the left-hand side, a voice over IP network on the right-hand side. The device here is able to convert from between TDM and voice over IP. I show here the different physical interfaces, the different voice codecs that are used on both sides or can be supported on both sides, as well as the signaling protocols that are involved on the TDM side and the voice over IP side. So a device such as the TMG3200 here can easily convert between TDM and voice over IP for any of these physical interfaces or any of these vocoding techniques, as well as any of these signaling protocols. And finally, here as a last example of an application, this involves the interconnection of two SS7 networks that are, say, possibly located in different countries. Network 1, Network 2. In this case here, I'm showing Network 1 uses a North American SS7 variant, and Network 2 uses a European SS7 variant. Let's say, for example, Network 1 is located in the USA, Network 2 is located somewhere in Europe, and we're using an IP network in between to interconnect these networks. And this is very often the case for international long-distance service providers which want to use voice over IP in between these two countries or two continents, but they actually need to connect using SS7 to terminate the traffic in these two different countries. So we can use a device such as the TMG3200 that's enabled with voice over IP to to provide this interconnection and actually convert between one SS7 protocol to another SS7 protocol, but at a distance over a voice over IP network. Notice that in the middle here I specifically mentioned the support for SIP-I, which is the transport of SS7 ISUP information over the SIP protocol, and this can be very useful to transport SS7 parameters which don't map very well into standard SIP protocols. So that was a section on applications and how you can use signaling conversion in your networks. Those are examples to give you some ideas on how these products are used. I'd just like to briefly provide an overview of Telcobridges T-SIG signaling gateways or signaling converters, and then I will conclude the webinar and answer questions if there are any questions. So in this slide here I show Telcobridges' product line, T-SIG product line of signaling converters. You see that we offer a low density, medium density, and a high density products. So the TSG 800, for example, supports from 1 to 8 T1E1s, whereas the TSG 3200 supports up to 64 T1E1s, but also DS3 or OC3. And we also have an even higher density product which can perform exactly the same functions. Let me show you here on the next slide all of the signaling protocols that are supported by these devices. I've been talking about SS7, talking about SIP, SIP-I, ISDN PRI, CAS signaling protocols such as, for example, E&M signaling on T1 or CAS R2 on E1. All of these protocols are supported by all of these devices, but as well as SS7 over IP in the form of SIGTRAN is available as well. These devices can generate call detail records and are easily integrated with your network operations support center using SNMP for management. And they all provide a web-based interface for configuration and management. Let me note here on the last row of this table something that can be important when you deploy these products, that is the number of completed calls per second the devices can achieve. I list here the performances for each of Telcobridges signaling gateways. These are industry-leading call handling performances, and depending on your application, it may become very important that the device be able to keep up with the traffic on your network. One last slide here just to show you one of the troubleshooting tools that are available in Telcobridges products. This one is called the Call Trace. All of the devices actually have a historical log of all calls it has handled with the associated signaling. So you can actually call up, you can actually search these logs for specific calls that you're looking for, maybe based on calling telephone numbers or called telephone numbers, maybe date and time. And you can actually display, and I'm showing a portion here of a ladder diagram that's displayed by the gateway, and you can actually see the signaling. You can see here on this example there's an IM message from SS7 that came into the gateway. This prompted a response of an ACM message, and the device actually displays some of the parameters that are included in these messages, such as the calling number and called numbers. It indicates the nature of address of the call, and some more information such as the circuit the call came in and so on. These are troubleshooting tools that help you diagnose your network and provide better customer service to your subscribers. Now finally, in order to conclude this webinar, would just like to provide a brief conclusion, and then I'll hand it over to Ashley while I have a look at the questions that I've been asked, and then I can come back and answer some questions. So just in conclusion, just want to say that the signaling converter devices or signaling gateway devices perform actually much more than signaling protocol conversion. They actually perform switching, and they actually handle the actual audio or voice or the media, and they're connecting two call legs from one network or device to another network or device, while adapting the protocol or converting the protocol and actually providing the ability to modify some signaling parameters such as calling and call numbers and nature of address, calling party category, and so on. And it allows you to solve network incompatibility issues, or actually allows you to extend the life of some legacy devices that you may need to support. Well, I'd like to say thank you very much for your attention. I hope you found the webinar interesting, and I'll ask Ashley to say a few words while I have a look at the questions that have been asked. Ashley?
Thank you, Mark, and thanks everyone for attending today. If you want to go back and review these slides and look at anything that you may have missed, the presentation will be up on our website shortly. And if you have any questions, you can reach out to Bobby Bain. His contact information is on the screen right now, and he should be able to help you with anything that you need. Thank you again, and Mark, do you want to do questions when you're ready?
Yes, sure. Yes, I'd like to do that. I have a few questions here by an attendee, and thank you very much for the questions. You've actually asked quite a few. That's great, and I'll be pleased to answer them now. The first question is, are you supporting German national ISAP, which is used to interconnect with Deutsche Telekom? The answer is yes. The signaling converters and voice over IP gateways provided by Telcobridges support more than 20 ISAP variants, which includes the German ISAP, but also many North American variants defined by ICE, NC, as well as ITUT and FC. Signaling variants, and also Japanese, Chinese, and so on. So the devices have been deployed in more than 80 countries, and so this is how we've come to implement these different variants. The next question is, have you done any conformance compatibility tests in Germany or Austria? The answer is yes. Tests have been performed in Germany. I have to say no, not in Austria. And in fact, it's not surprising, because when we do deploy these devices, these compatibility tests, at least in the carrier network, are often performed, and very often country homologation tests are required, and this is standard practice. The other question is, how detailed can protocol conversion be done? Are you able to change information elements on the fly according to rules that are configured in the signaling converter? And the answer is yes. The information elements from, say, one protocol can be modified or changed before they are adapted to the other protocol. I will say, though, that not all of the information elements are supported, but a very large number of them are, and the main information elements, the ones that carriers often need to manipulate most, are all supported. And it's quite easy to do so, and all of this is performed on the fly. The other question is, the device able to transfer the whole ISDN supplementary feature set over a SIP path and translate it back to ISDN at the switch? The answer is yes and no. Possibly, sir, not all of the full supplementary feature set. The important ones. Actually, Telcobridges has a wiki online, and if you search on this wiki, which is located at docs.telcobridges.com, docs.telcobridges.com. If you search that wiki, you'll be able to find all of the signaling parameters that are supported and that you are able to manipulate and that are bridged between ISDN, SS7, and SIP networks. And I think the other question here is, what about soft switch features? I think that's what it means. These devices implement a full call routing engine which allows you to perform call routing based on called telephone numbers, calling telephone numbers, as well as trunk group routing, incoming trunk group routing, as well as load sharing or percentage routing, as well as least cost routing. These devices implement a very extensive call routing engine. Maybe Ashley, we're going a little bit over 30 minutes here. Maybe I can answer one more question here. It says here we're running a very old TDM CAS-based tandem and would like to interface to our SS7 network. Can you support custom CAS variants on T1? And the answer is yes. Our implementation of CAS signaling or channel-associated signaling is based on scripts. And this is true for both CAS R2 signaling as well as T1 CAS or CAS R1. These scripts are editable, modifiable by our customers, but also our customer service team can support you in adapting a CAS variant or implementing a specific CAS protocol. So you can edit the script to modify timers, change ABCD bits that need to be transmitted. You can use it to change the significance of tones, MF tones, multi-frequency tones or DTMF tones. You can modify timers. You can adapt the signaling to, say, a slower device or slower network. In the case of like an E&M signaling, a wink, which is an AB bit transition, may be required at different times depending on the device we're connected to, and you can implement all of this and adapt it and customize the script for these CAS signaling protocols. So that's it. I'd like to say thank you very much for the questions that that have been asked. Those were very interesting and allowed us to add some content to the webinar, and I'd like to thank you for your attendance. If you'd like to find out more, you see the contact information here on this slide. Our partner Pulse Supply is able to provide you pricing on these products and help you with the system integration or design, or ensure that the products will work in your network. And of course, we're available to help you understand these products and how they can be used in your network. Thank you very much. Ashley, do you have anything to add?
No, that's it. Thank you again for attending. We hope you found it informative.